The engine uses a design pattern called entity component system, and it's a very nice pattern because it's versatile. It can be used in a lot of different domains. It's not really specific to one type of problem. It's scalable, and that's one of the big pluses, is that you can have thousands and thousands of these things called entities, which we'll talk about later, and it runs fine. It's efficient, which goes along with the scalable part. It minimizes code duplication in a lot of ways that seem kind of counterintuitive when compared against, say, inheritance, and we'll cover that as well. It's very easy to use once you understand the principle and once you have the framework in place. And it is reusable, and this is kind of a token term or benefit that people like to throw at things like object-oriented programming or maybe other design patterns. But at its core, the entity component system pattern doesn't make any real assumptions. So the components that are generated from this really are reusable at the very base form. So a component is really just kind of a data container. It doesn't have any functions. It can have functions, but it's generally advisable not to put too much functionality in it. Um, and it needs to in some way be serializable. It needs to be able to dump itself into a stream or a database of some kind. And maybe it's not responsible for doing that, but in our engine system, the components are responsible for serializing themselves. Um, the other requirement is that it has an entity ID property. Other than that, it can have any kind of custom data format that the user or programmer wants to put in there. And the entity ID is included in the base component class, so it just gets inherited in. And really, the only effort needed to make a new component is just making a new class that inherits from component. Now, entity is a very vague term. Entity can represent pretty much anything, any conceptual idea, and that's exactly the point, is that the entity really is just a thing. It's something that can be thought of. It's a noun. And so the way that you represent an entity in the ECS pattern is by a set of components. So anytime you want to make a new type of thing, you don't make a new entity class, you make possibly a new component, but maybe not. You might already have the components that you need to make that new thing. Um, the main requirement of the entity is that it has an ID, and so that's where the components, they store the ID, and all the components that have the same ID belong to the same entity. It also has something called a signature, which is just the term that I give to the unique set of components that make it up. So if an entity has components A, B, and C, then its signature is ABC. And this gives you a lot of set operations, and you get all the guarantees that come along with sets, like subsets. Does it contain this component? Is there any kind of intersection between these two signatures? Those sorts of things. So you might be asking, where do I actually put the code associated with these entities? And this is where the pattern sort of diverges from the object-oriented norms in the sense that the system contains functional procedures and functions that operate on the entities, but it's not specific to one type of entity. The system only cares about a certain set of components primarily, and it typically implements an update function that gets called periodically, either 60 times a second or less or more. But that update function will operate on a subset of the entire set of entities in the world based on their signature and their location. Um, a system can communicate with other systems through the use of information on components, or they can use the event system, whereby the observer pattern is employed, and one system fires an event, and then any other systems that happen to be listening to that event will be called. You can also have direct dependencies, where one system actually includes the header file of another system, and then it imports it in its constructor, and so forth. here's a bird's eye view of everything put together. And so you could see at the highest level of the programmer's perspective, you have the systems. So if you're going to add some new functionality, you're typically going to add a new system. And then you may also add some more components, depending on what kind of entities you need to manipulate. And systems are normally just going to make queries to the entity manager, which is pre-built. It's part of the engine, but it manages all of the database interactions and making sure that queries are efficient and they return the right set of entities. And so the entities themselves are typically returned to the systems, and then systems can also generate entities and send that back to the entity manager. So everything from the entity manager down in this diagram is not visible to normal user code. I figured a good way to show the power of this pattern in action is through a small application. So if you consider these four types of objects, these four classes, if you will, you have the arrow, which has presumably some sort of visible component and it moves in the world. You have a ghost, which ghosts move around and scare people, but you can't see the ghost. You have a rock, which we're going to assume is just a stationary object that you can see, and a map marker, which will kind of be displayed on a mini-map somewhere. So the question to you is, how would you implement this with, say, inheritance? One solution, and there are of course many, is to say, okay, all of these have some sort of position. So let's make a position entity base class. And then extending that, we have those entities that have a model that you can see, and the ones that can move. And so, the rock has a model and a position, the arrow has a model and a position, but it can also move. And that's kind of interesting because you see this double arrow that's multiple inheritance. Now, most languages don't actually allow you to do that. C++ does, but you might not necessarily have that guarantee. So that's already a sort of point of contention with this, is that you have these situations where you need attributes from two separate base classes, but you may not actually be able to mix them together in a reasonable way. And so then you have the ghost, which moves, and the map marker is just kind of its own thing that really only inherits position. So, first of all, in solving this problem, you can probably see how it is ambiguous in the sense that this isn't the only way to solve it, and there's a lot of sort of abstract thinking that goes around this conceptual model. There's also a high chance for code duplication because of this multiple inheritance problem. You might have situations where the attributes that are being inherited from two different classes don't exactly mix well, and you need to sort of turn off some features from one and pull in other features from a different one, and it just creates really this big mess. This might be the solution that's implemented in the ECS pattern, whereby you have a position component, a movement component, a model component, and a map marker component. And those components are just small atomic objects that only have information associated with what they're actually representing. And so, the arrow has a position, it has a movement, and has a model. The ghost moves, and it has a position. The rock has a model and a position. And the map marker has its special map marker component and a position. So overall, I've only made 4 classes here. See, the arrow, ghost, rock, and map marker objects themselves are not classes because they're just signatures. The only real classes here are the components. It has a meaningful abstraction in the sense that these components actually make sense in the larger world. You can reuse them. A movement component is something that is, it's not very ambiguous. It ties you down to knowing exactly what it's representing pretty well. And it's scalable because, like I said, these are reusable and they don't really make too many assumptions about what they're representing. Going forward with this example, if we want to update these entities, we might have a render system that only cares about entities with a model and a position component, in which case it's only going to render the arrow and the rock, which is what we want. The movement system likewise only cares about movement and position, so the arrow and the ghost get updated. And the map system is just kind of a one-off. It only cares about map markers in this case, so it'll only operate on the map marker.